Hello everybody, my name is Alan, and welcome to lesson 3 of the series. This series is about making a model that even AI cannot do. If you want to know more about the model, you can check out lesson 1 and 2, but I'll go over what we did briefly. So, in lesson 1 we created a cylinder with the air valve at the top and the water valve at the bottom. In lesson 2, we created the animation where this tank implodes. So in this lesson, we're going to create an animation with the water. So what we do first is we go down to add clock simulation, and we create a new defined function called setup fluid simulation. And then the parameters are domain size, inflow location, and the inflow start frame. So what does this do? What are these parameters? So the main size is the size of the domain. The domain is the area which the water can flow. And inflow, I will explain to you what inflow means later when we get there. So we could comment that the setup fluid simulation with a domain and inflow for water flow. Then we create another comment that says create the fluid domain, which is what we're going to do in the next few lines. So we write a ops dot mesh dot primitive cube add, and then create add. The size is domain size. Location is 0, 0, domain size divided by 2. So what does this mean? So the size is just the domain size we put in the parameter. The location is just the location of this object. The main size divided by 2 is the z for the location. So why do you divide the domain size by 2? Well, the domain size is just making sure that all the lengths of the cube, like for the height, the length, and the width, are the same. So, and the length of all of those are domain size. And dividing the z location coordinate, we get the middle of the cube. So that's why. So this makes sure that the cube is not like up here, but over here. So that's the purpose of the main size divided by 2. Next line, domain is equal to bpy dot contact the object, which we give a name to this object. It's called domain. Domain name So we give it a name in the blender, but we're going to use domain for Python. Next, we're going to set the domain material. So domain material is equal to bpy dot data dot materials dot new name is equal to domain material. Domain material dot diffuse color. Start giving this domain its color. 0.8, 0.8, 0.8, and 0.2. So, what is this color? It's like a dark gray transparent. How is it transparent? Well, these parameters are red, green, blue, which is for like some of the colors using RGB. But this last parameter is the opacity. So the larger the number, the more opaque it is. So a very low number, like 0.2, makes it transparent, and this makes the cube dark gray because we want to see through the domain cube to see the water. Next, domain data materials append domain material, which is just using this. Okay, now we do this and configure the domain as a fluid domain, because you want the Python and want to know what kind of domain this is. The object dot modifier add type equals fluid. So we add a fluid modifier, which is kind of like the cloth modifier we added last lesson to the implosion animation. And then fluid mod is equal to domain dot modifiers -1. So it takes the last modifier of the domain object, which is fluid. So that's what it is. That fluid mod dot fluid type is equal to domain fluid mod dot domain settings and then we copy this because we're gonna be typing this a lot. Domain settings dot domain type is equal to liquid, and then we're at resolution max equal to 64. So why do you want the resolution to be 64? Well, it's because the 64 resolution allows you to changing the aspect ratio, so it's easier to change with this resolution. we copy again, then use mesh is equal to true. Use liquid mesh for rendering. Okay, now I realized that I put this domain inside this define function, so we have to do this really quick. Now we have some code that we create the fluid inflow object. So we create an object relative primitive cube add size is equal to 0.2. Location is inflow location. Inflow is the name of the object in Python, and the name in Blender is fluid inflow. Next, we set the inflow material. Bpy.data materials.new. Name is equal to inflow material. Inflow material color is equal to 0, 0, 1, 1. So blue for water is not transparent, so it's 1. Data materials dot append inflow material. Next, we're going to configure the inflow as a fluid inflow. So dot ops dot object dot modifier at, and the type is fluid. Inflow mod is equal to inflow dot modifiers -1. So it's the same thing as domain. We just take the last modifier, which is fluid. Inflow mod dot fluid type is equal to flow. Flow mod dot flow settings dot flow type is equal to liquid. And then the last settings, the flow behavior. Without an L is inflow. Okay, now we can animate the start of the inflow. inflow mod dot flow settings. And then we're going to copy this because we're going to use this quite a bit. Dot use inflow is equal to false because initially it's off, that's why it's false. But it's going to turn true later. So keyframe insert data path is equal to use inflow. The frame is 1. So from frame 1, the use inflow setting is false. Inflow mod flow settings. Then we turn it into true because we are going to have a flow animation. Now we're going to insert the keyframe where that happens. The frame is equal to inflow start frame. Now we have to set the velocity. Inflow mod dot flow settings dot velocity factor is equal to 1. Then inflow mod dot flow settings dot velocity normal is equal to -3. So direction of flow, which is downwards. And then this slide enables velocity. And then we're done with this defined function, so return domain and inflow. Now we go down to where it says create collapse simulation. Go after the water valve code and the domain inflow is the setup fluid simulation. So now you're using the fluid simulation. The domain size is equal to 8 because 8 is able to cover the space that inflow needs. And then it's into the location. It's equal to 0, -3.5, and 0.7. Why? It's because those coordinates are exactly like around here, which is the water valve, which is where we need the water to flow out. And then flow start frame is 40, which is where this valve also opens up fully, so that makes sense. Now we run in. I did a lot of typos here. Diffuse I misspelled. we can just check the typos. And we're done. So, it's going to be extremely laggy at first because it's still processing and that stuff. However, after the first time, it's going to go back to normal speed. So you see, this is the water, and it's flowing out, and then the tank is still collapsing. Now we can see it's normal. However, there's still one problem that needs to be fixed, which is the cube on the outside before frame 40 and the flow starts flowing. So we want to fix that. So let's go back to our code and let's go in between the configuring the domain and create a fluid info object. And we're gonna write domain scale 0.01, 0.01, and 0.01. So we're making this cube very small. Domain.keyframe. Insert scale frame equals 1. And then we copy and paste this again. So in scale and frame 1, the domain scale is very small. But it's also the same. It's also that small. When the frame is equal to inflow start frame. Nice one. So one frame before this starts flowing. Now, what's this cube gonna do when it does start flowing? We need the cube to be around the box so the water can flow. I'm gonna domain scale is gonna be back to more at 1, 1, 1, and then the keyframe insert is gonna be inflow start frame. So right when this water starts flowing, the domain box is gonna be the same. It's gonna be what it's supposed to be. And I forgot to add the equal sign, but we can fix that. Now it should work. And I flame instead of frame. Okay, now it's done. You can see there's no cube and it's before frame 40. Now you see it's done with the first laggy run, and there's no cube anywhere. I mean, it's over here, but you can easily get that out. So, that's it for this lesson. Next lesson, we're going to make this look more realistic. So, bye.